Okay, so for 4.17, I want to solve using Gauss-Jordan elimination. Whoa, what's that?
Is that times or minus?
This? That's a hyphen between two words. That's Gauss-Jordan elimination.
Joe?
Yeah.
That's where you multiply the top one by -2, right?
Yeah, this is kind of the analogy of regular elimination, where you multiply the top equation by -2 and add them together so the x's would drop. Yeah.
Or substitution.
Yeah, or substitution would be another method. Gauss-Jordan elimination is the elimination you do in matrices. But let's just do regular elimination, because I think that's chillier. You all cool with that?
What's Gauss-Jordan?
So let me try with regular elimination first, and then we'll play Gauss-Jordan games. So for regular elimination, I would take the top row, multiply it through by
2.
-2. So I got my bottom row is 2x minus 5y equals 13. And then second row times -2 is minus 2x.
Plus 5y, or plus 10y.
No, 6.
Okay, that row's that one. This one got multiplied by -2. So I got minus 2x
Minus 6x. 6y, sorry.
minus 6y equals
1.
1. No. Equals
Wait, it's not there.
2. Oh my
You don't
god.
multiply with it.
Negative
Okay.
2.
what? No, this is wrong.
It's 2.
Yeah, that's what I was, okay.
So you take the entire top equation, right? All of it. Whole thing, multiply by -2.
Yeah.
You guys all good with this?
Yes.
Okay, then what?
Then you add them together.
Then you add them together, and you get no x's, and a minus 11y equals 11. And then you divide, so you get y equals -1. You guys all good with that?
Yes.
Where does the x come in?
Now you plug,
You plug it in.
the y value into the second equation, or the first.
Yeah, I'm going to plug it in the first equation, because that's going to be easier.
Okay.
So I think I got, out of the first equation, I'm going to get x minus 3 equals 1.
Wait, what did you just
X equals
I did this. I took y equals -1. Right? I brought that up there, shoved it in for y, and then I brought the result back down over here.
Oh, that's the result.
Okay? Then add 3 to both sides.
Yeah.
So you get x is
4.
4. Check done. That's regular elimination. Okay, for Gauss-Jordan elimination, I'm going to make a matrix out of this thing.
Wait, why did you do that?
Why would I do that?
Do we have to do that?
You have to know how to do that.
Are we gonna have to do that on test stuff?
Yes. It is not hard. It's not hard. It's not hard. So, because we were fiddling with this one, I'm going to use this one, where I flip the order. So, to convert to a matrix, I'm going to take that second equation, and I'm going to write it up here. 2 minus 5, 13. You guys with me on that?
No. Why?
I flipped this over.
What? Is it gonna be like a 3 by 3, 2 by 3?
It is 2 by 3. So this is a 2 by 3 augmented matrix. So I took the 2, that was the thing on the x's, I put that in the first slot. I took the minus 5, that was the thing on the y's, I put that in the second slot. And I took the 13 and put it on the other side of the equals thing. The reason I'm flipping this is just that I want you guys to see this in it. So the top equation, what's the x?
1.
Okay, there's 1 is the coefficient on x. What's the coefficient on y?
3.
Trace. And the coefficient on the other side?
1.
Or the number really on the other side is 1. Okay? So then, in Gauss-Jordan elimination, your goal is to get a 0 here first. So you can do the same things you can do with equations over here, which is just multiply through by numbers and add equations together. That's what you're allowed to do. So if you take this equation, multiply through by -2. So I'm going to multiply, I'm going to make row 2 twice row 2. Oops, minus twice. So I'm going to rewrite this system. 2, -5, 13, -2, -6, -2.
Didn't we do this like yesterday or something?
Yeah. Also right here. Like this one I just did a second ago,
No,
right?
I meant like this, like gas for.
Yeah, we did Gauss-Jordan the other day.
Yeah, that's it.
You guys see that I actually just did this a second ago too? That was my multiply by -2 step. I have that exact same thing right here. I'm going to do the exact same thing over here. I'm going to take row 2 and I'm going to make row 2 equal to row 2 plus row 1. What? So I'm going to leave that first row alone, my 2, -5, 13. And in the second row, I'm going to put the result of adding. You guys see that? So 2 plus -2 is 0. And -5 plus -6 is -11. And 13 plus -2 is 11. You guys see that's the same thing I had before over here? So the advantage of this is 1, I'm not writing down lots of x's and y's and maybe losing one. Right? And 2, it's pretty organized. So when we do the 3, I'm going to show you a 3 by 3 example today.
Thank you.
If you try 3 by 3s without the matrix, it gets to be a giant disaster in a hurry. Because there's 3 variables you can kind of chase about. And you pretty quickly end up swapping back and forth and back and forth and forth and back. And you just draw a big circle on the board with algebra. The only way you ever get anywhere with it is when you screw up. Right? But this thing gives you a nice, easy organization to follow.
So that's your answer.
So this bottom one gives me that same -11y equals 11. Right?
Oh.
You guys see that? There's no x's, minus 11y's equals 11. Okay, so I'm back to this spot, and I can just back substitute from there.
Wait. Can you go over exactly what you just said?
Yeah. This equation here. That guy? That thing reads 0 x's minus 11y's equals 11.
Okay. Okay.
Which is exactly this thing. And then you guys know how to get the other variable once you have 1. Right?
I think so. Maybe you should go over.
You do this thing. You take the variable you know, you stuff it in one of the equations, and you solve.
Okay, I didn't know you had to do it.
So if you want to do it with a matrix, let me show you how to do that. It only takes a second. So take this guy. Oops, wrong color. Multiply row 2 by 1 over 11 minus 1 over 11. So top row stays 2 minus 5, 13. Bottom row becomes 0, 1, -1. You guys see that's the exact same thing I did to find y was -1 anyway. So you had to do that step anyhow.
Yeah.
And then once you're here, you can say, okay, so if I take this second row, if I multiplied that row by 5, I'd get 0, 5, 5, right?
Negative 5.
Perfect. Thank you.
How'd you get that bottom row? The second row?
So the second row came from taking this second row and dividing by -11.
Why?
Just a K or Y.
Then this guy is me thinking about row 2 times 5. See that?
1Y equals -1.
Yeah. This says 0x's 1y equals -1. So that's y is -1. This other guy says 5y equals -5. Right, that's what the little red one says. If I add this top to the red, so that's me doing the step row 1 turns into row 1 minus 5 row 2 plus 5 row 2. But the red is 5 times row 2. And I'm just going to add that to row 1. So I get 0, 1, -1. And in the top, 2 plus 0 is
0.
2.
Oh, sorry, I was thinking multiplication.
0 is the next one.
and then minus 5 plus 5 is
0.
0. And 13 minus 5 is 8. So now what does that top row read?
2x plus
2x plus 0y equals 8. Which says 2x equals 8, right? So you can take this and you could do row 2, or row 1 rather, is row 1 over 2. And you'd get to 1, 0, 4, 0, 1, -1. You guys with me on that? Which tells you x is 4 and y is -1. Check. Done.
So could you just, like, when you got the 0, -11 down there?
This guy?
Yeah.
Yep, you could jump over to this technique if you wanted to. Is that what you're gonna ask?
Yeah.
Yeah, totally. If you get to a point where you know one of the variables and you think you can get to the end from there, pop ahead and do an old technique. That's totally cool.
Okay.
You can do that on tests too?
Yeah, I don't mind.
So, like, when you tell us to solve with that type of elimination, should we start with the regular one and then go down, or just start with that?
Oh, I would start with the matrix. So honestly, if I was you guys on exams, I would do convert to matrix, and then let me write this in a different color. Punchline. Calculator. Right? And I would literally draw that arrow. Like really, what I expect from you guys is just say matrix, matrix, arrow with calculator written next to it, result. Right? And then from here, I expect you to say, so x is 4 and y is -1.
That was my question.
Yeah, you were asked a question about x's and y's, right? So you should answer in x's.
That's what I was wondering, so when we're doing it in this method, we still need to give an answer in x and y.
Yep. You guys all good with that?
If we wanted to, just for fun, like just until, not for fun, but until we get used to it, still keep the variables up there.
Oh, like
I know
hanging
it
in the
would say- I know it would
matrix?
say 0 x's or whatever, but keeping it in the matrix just to,
Don't keep them in the matrix, but if you want to keep them up here or
Right.
something, I'm down with that.
okay,
But don't put them in there.
not forever, it's just like still adding, like when you were getting used to using variables,
Yeah.
still putting a 1 next to the variable, just for bookkeeping.
Yeah, that's totally fine. You guys all good with that? Okay, I want you guys to get a little practice with this technique though, because later we're going to learn a thing called the simplex method, where you have to use this idea, but you can't get the calculator to do the simplex method. It's not smart enough. Okay? So you gotta get a little practice with this by hand, but you could totally check it with a calculator, and you should. Cool? We good? Okay.